All right, so this is section 18.5 on equipment replacement problems. So just a brief little intro here. Many companies and customers face the problem of determining how long a machine should be utilized before it should be traded in for a new one. Problems of this type are called equipment replacement problems and can be solved with dynamic programming, which is just the theme of the chapter 18. So basically what we're working with here is just any sort of situation where equipment starts to get bad, and we need to figure out when the best time is to replace it versus repair it. So going into this first example, we have an auto repair shop that needs to have an engine analyzer, that's our equipment, and a new engine analyzer costs $1,000. The cost of maintaining an engine analyzer during its ith year of operation is first year, or 1 year is $60, second year is $80, third year is $120. We can only keep an analyzer for up to 3 years, then it has to be replaced. And we have our salvage values here, S sub I, where S1 is 800, S2 is 600, S3 is 500. Given that we purchase a new machine at time 0, we need to figure out the best replacement to get a machine for the next 5 years. So what we're doing here is we're trying to minimize our cost here. So I'm going to write min, just call it Z. And this is going to be, we're looking at our maintenance cost plus the replacement cost minus the salvage cost, because when we sell it, we're going to get money back. And then we have to add our g of x function to incorporate the other time points here. So all of this here is just going to be our cost function from T1 to T2. And basically what we're looking at here is we've got this big time frame here. This is going to be time 0, time 1, time 2, 3, 4, and 5. And we need to figure out with these points what the optimal repair versus replace situation is going to be for us. So first we're going to define our general costs here. So we know that if we do just 1 year with the machine, this is the same thing as going from time 0 to time 1, or time 1 to 2, or time 2 to 3, time 3 to 4, or time 4 to 5. And what this is going to equal is $1,000, which is our cost for our new engine, plus the maintenance cost here for 1 year, minus the salvage value if we sell it after 1 year. So again, I'll just kind of label those. This is to buy it new. This is our maintenance one. And then we're subtracting our salvage one. So when you compute all of this, 1,000 minus 800 plus 60, that's just $260. Next, we should look at if we do 2 years here, which is the same thing as going from time 0 to time 2, time 1 to time 3, time 2 to time 4, or time 3 to time 5, which again is going to be that $1,000 for new, plus that first maintenance cost of 60, and that second year of maintenance cost here for 80. And then we're going to subtract off our secondary salvage value here, because you only get one salvage value. And when you compute all of these together, 1,000 minus 600 plus 60 plus 80 is just going to be 540. And then we have 3 years as well here, which is going to be from time 0 to 3, time 1 to 4, or time 2 to time 5. And once again, we have $1,000 for the machine, plus $60 for maintenance 1, plus $80 for maintenance 2, plus $120 for maintenance 3, minus the $500 salvage value, which is going to give us a net total of $760 here as a cost. So now that we have kind of our cost points labeled here, we're going to start off by We're going to start at time 4 here because we know that time 5 is going to be the end. Well, actually, I'll even write that down up here. Let me start. We know that since time 5 is the endpoint, we know that our g of 5 function is just going to be equal to 0. So then moving forward, for time 4 here, we've got our equation g of 4 is going to be equal to, well, there's only one way if we're at time 4 that we can proceed, which is going from year 4 to year 5. And then we have to add on that g5 function, which in this case is just going to be 0. So again, now we have cost from year 4 to year 5, which we computed up here, which is just 260 plus 0. So we're looking at $260 for our G4 function here, which what this is saying is if we buy at time 4, we should sell at time 5, which is pretty self-explanatory because that's our only option here for at the point time 4. But now we can go back to time 3 now that we have our G4 function here. So for G3, we have to figure out the minimum cost here with our two options. Option number 1 is we can buy a machine at year 3 and sell it at year 4, and then we have to add on that G of 4 that we just found, which in this case is going to be 3 to 4 up here is 260, plus our G4, which we just found, is 260, which is going to give us a value of 520 here. Or on the alternative, we can keep a machine from year 3 to year 5, and then we have to add on our G of 5 value here, which we have up top. So that's going to be cost from 3 to 5 is going to be 540, plus G of 5 is just 0. So we're looking at a cost of 540. So between 520 and 540, we're going to take the cheaper option, which means that if we find ourselves at year 3, we should buy at year 3 and sell at year 4. Now we move on to T2 here. So to find G of 2, we now need to find the minimum of, we've got 3 options now for what we can do from time 2. We can buy at year 2 and sell at year 3. And then we have to add on our G of 3 that we just found. So that's going to be 2 to 3 is $260, plus G of 3 we found is 520. Add these two numbers together and you have 780. We can also go from year 2 to year 4, and then we have to add on our G4, which is going to give us from 2 to 4 here is 540, plus our G4 is 260, which is going to give us a value of 800. Or we can actually go from year 2 all the way to year 5 and add on that G5 value. So 2 to 5 down here is 760. Adding our G5, which is just 0, gives us 760 here, which is going to be the lowest of the 3 options. So if we find ourselves at year 2 here needing to make a decision, we should buy at year 2 and sell at year 5. Now we go back to time 1, G of 1, which is going to be the minimum of, we've still only got 3 options here now because a machine can only last for 3 years as they defined in the problem. So we're looking to go from year 1 to year 2 and add G2, which would be 1 to 2, which is just 260, plus G2, which is 760 in this case. And that's going to give us a value of 1020. We can go from year 1 to year 3 and add G of 3, which is going to be 540 plus our G of 3, which is 520, which is going to give us 1060. Or we can go from year 1 to year 4 and add G4, which 1 to 4 is just going to be 760, plus G of 4 is 260, which gives us a value of 1020 here. So now we actually have two minimums because they're both equal to 1020, which basically means that if we buy at year 1, we can sell at either T2 or T4, and it's going to be the same minimum cost for us. And I am running out of space, so I'm actually going to move over to the side here. Lastly, we have to account for T0 here, where we start at. So to find G of 0, we need to find the minimum of going from year 0 to year 1 plus G of 1, which is going to be up here, 260 plus G of 1 we said was 1020 down there, 260 plus 1020, which is just going to equal 1280 here. We can go from year 0 to year 2 and add G2, which is going to be, I have them kind of memorized by now, 540 plus, and we said G2 is 760. So 540 plus 760 is 1300. Or we can go from year 0 to year 3 and add G of 3 onto that. So that's just going to be 760 plus G of 3, which here is going to be 520. And that's going to give us 1280 as a cost. So again, we have a tie here for the minimum with 1280. So we can say if we buy at year 0, we can sell at either year 1 or year 3. So now we've reached the base of the problem here. And because we have all of these alternative options here, we actually have a couple optimal solutions. So we can do some buying and trading because we need a machine at all times. At times, we're going to start at t equals 0, of course. And then let's just arbitrarily say we sell at time 1. That's going to put us over here at T1, which we decided we can either go and sell at T2 or T4. So I'm going to pick T2. So now we're selling again at year 2. And then we know up here if we buy at year 2, we need to sell at year 5. And then now we're at the end of the problem here. We can also buy trade at times, again starting at t equals 0. If we go to year 1 again, take this over, now we can go to time 4 and use this option. And then from time 4, we know that we have to sell at time 5. And then if we buy trade at times, again starting at t equals 0, this time if we go to T3, then if we're at T3, we see that we sell at T4, and again, T5. So these are our options here for what we can do to spend the least amount of money and have a machine for all of these years here. And all of these options, we're going to have a net cost of our G0 function up here, which is just going to be 1280. So again, all three of these solutions here are equally optimal. They're all going to cost us the same low amount of money. You can just kind of pick whatever one works best for the company. So now moving on to the problem down here, we have a new car that costs $10,000, and the annual operating cost and resale value of the car are shown in the table below. If we have a new car, determine the replacement policy that minimizes the net cost of owning and operating this car for the next 6 years. So here we're going for 6 years. So we're going to go from T0 all the way out to T6. And again, I'm going to start off by defining those costs that we just defined to start in that last problem. So if we're looking at 1 year, we can go from 0 to 1, from 1 to 2, from 2 to 3, from 3 to 4, 4 to 5, or even from 5 to 6 here. And this is going to cost us $10,000 for the new car, plus we've got in the table here $300 for operating cost, and then we have to subtract off $7,000 here for the resale value, because that's going to be money coming back to us. So again, I'll just label these operating cost and then resale, and this is going to sum out to be $3,300. For 2 years with a car, we're going to go from either 0 to 2, 1 to 3, 2 to 4, 3 to 5, or 4 to 6. And this is going to cost us that $10,000 for a new car, plus the operating cost, which is $500, minus the $6,000 resale. And that's going to be a total of $4,500. For 3 years, we've got year 0 to year 3, year 1 to 4, year 2 to 5, or year 3 to 6. So again, 10,000 plus that $800 for the operating cost, minus 4,000 for resale. And that's going to give us a value of 6,800 cost here. If we keep a car for 4 years, we can go from 0 to 4, from 1 to 5, or 2 to 6. And this is going to be $10,000 new, plus $1,200 operating costs, minus $3,000 here for that salvage cost here. And this is going to give us a value of 8,200. And then if we have the car for 5 years, we can go from 0 to 5, or from 1 to 6. And that's going to be $10,000 for the car, plus 1,600 operating costs, minus $2,000 for that resale. That's going to be $9,600 for an overall cost. And then lastly, if we keep the car for all 6 years, we're going to have $10,000 plus $2,200 for the operating cost, minus a $1,000 resale. And that's going to give us a cost of $11,200. So now that we've defined all of our baseline costs here, much like the last problem, I'm gonna run out of space. It's okay. We know that at the end here, g of 6, it's just going to be 0. So we can start at T5, which is going to give us g of 5. And there's only one thing we can do at g of 5, which is go from 5 to 6, and then add on g6 at the end, which from 5 to 6 up here is just going to be 3,300 plus 0 for g of 6 gives us 3,300. And that's our best option, our only option. So if we buy at time 5, we should sell at time 6. Now we go on to T4, which is going to be G of 4 equals, well, we have a couple options now. We can either go from 4 to 5 and add on G of 5, or we can go from 4 to 6 and add on G of 6. So 4 to 5 up here is going to be 3,300 plus G of 5, which is 3,300. And then going from 4 to 6, we've got 4,500 plus G of 6 is just 0. So between our options of 6,600 and 4,500, 4,500 is obviously the lower option. So if we buy at T4, we should sell at T6. Going on to T3 here, we've got G of 3 is equal to the minimum of, we can go from year 3 to year 4 and add G4, year 4 to year 5 and add G5, or year 5 to, oh, I'm actually making mistakes here. We can go from 3 to 5, or we can go from 3 to 6, is what I had meant to write. And then again, these are going to be, the cost from going to 3 to 4 is 3,300 plus G of 4 is 4,500, we said. 3 to 5 is going to be 4,500 plus G of 5, which is just 3,300. Or we can go from 3 to 6, which is here, 6,800, and add 0 for G of 6. So that gives us the options here of 7,800, 7,800, and 6,800. So we're going to take 6,800 and say that if we buy at time 3, we should sell at time 6. Moving on, we can do T2 now. So G of 2 is going to be the min of, now we've got quite a few options here. We can go from year 2 to 3 and add on G3, 2 to 4 and add on G4, 2 to 5 and add on G5, or 2 to 6 and add on G6. So 2 to 3 is going to be 3,300. Then we add on G of 3, which is 6,800. I'm just grabbing these numbers from one above now, so I don't have to keep going up. 2 to 4 is that 2-year jump, so 4,500 plus G4 we said was 4,500. Then we've got 6,800 plus G5, which is 3,300. And then 2 to 6 is going to be right here, 8,200 plus 0 for G6. So we take all of these sums and we end up with, let's see here, 10,100. This is going to be 9,000. Again, 10,100 or 8,200. So we're going to take that 8,200 as the min, and we can say that if we buy at T2, we should sell at T6. And we go down, which that's not right. T1 is going to be G of 1, which is our minimum of, now we can go from C1 to, 1 to 2 plus G of 2. We can go from 1 to 3 plus G of 3, 1 to 4 plus g of 4, 1 to 5 plus g of 5, or 1 to 6 plus g of 6. And again, following the exact same computations we've been doing, I'm going to not write it out to save a little bit of time here. We do have, did I write them down? This is going to be 11,500, 11,300, 11,300, 11,500. That's one too many zeros. Or 9,600. So that's going to be our best option. So we can say that if we buy at time 1, we should sell at time 6. Then lastly, we can take time 0 here and find g of 0, which is going to be our minimum of. We can go from 0 to 1 plus g of 1, 0 to 2 plus g of 2, 0 to 3 plus g of 3, 0 to 4 plus g of 4, 0 to 5 plus g of 5, or 0 to 6 plus g of 6. And you can see how the computation gets a little bit heavy for these. But again, I'll just write down the solutions. It's the exact same process we've been doing where I'm just grabbing these numbers from above. This is going to be 12,900, 12,700, 13,600, 12,700, 12,900, or 11,200. So the cheapest option is 11,200, which means that if we buy at time 0, like we're going to have to, we're going to want to sell at time 6. So now to conclude this whole big problem, our optimal solution is just going to be buy at time 0, and then we're just going to sell at time 6. And this gives us a net cost of $11,200. And that wraps up section 18.5. Thank you.